for section 7.5 today. It's trapezoids. Can anybody tell me what a trapezoid is? Yes.
It is a quadrilateral.
It is a
with
quadrilateral.
one set of parallel sides.
That's correct. It's a quadrilateral with at least one pair of parallel sides. Now, is a parallelogram a trapezoid?
Yes.
Yes, it is. A parallelogram is a trapezoid because trapezoid is just a little bit less constraining. So we actually kind of started with the most constraining. You start, well, actually square is the most constraining, okay? It goes up to a rectangle, okay? A rectangle goes up to a parallelogram. What's weird is off the parallelogram, there is a rhombus. It doesn't fit, that didn't draw very well. It doesn't fit here or here, but it's a parallelogram that's a little more specified because the sides are all the same. It's like a square, but it's not got 90-degree angles, okay? These have 90 all equal angles, all equal sides. These are 90. Opposite sides are the same. These are parallel to one another, and therefore they're the same size. But this one is parallel with all four sides the same. So now we're going up and we have what's called a trapezoid. But all of these fit inside a trapezoid. Because the only thing here is you have to have one pair of parallel sides. Well, all of these have one parallel side. These are just a little bit more specific. Okay, so it's kind of like if you identified this as a dog, but now I go down into what breed of dog this is. Okay, and then I might go down into its genetic makeup. How much, like mine is an Aussie poo. But I actually had DNA testing done on it, and it's not just Aussie, it also has Border Collie. So it's Border Collie, Australian Shepherd, and Poodle. So I keep breaking it down into more specifics, but overall it's a dog. Okay? And so it's one of the oodles that's around because everything oodle is very expensive right now. But I got mine free, which is really nice price. I went onto a website that's called, what's it called? It's a free rehoming website. And so people will offer their dog, they just can't keep it anymore. And so I got a dog that was for free for, it was a year old. And she just it was too busy for her and she didn't want to keep it. So these get more and more specific. So we only have to have one pair like this that's parallel, okay? And we're going to find out there is one other one that's inside this that doesn't fit into the others. So this is a trapezoid. It just has to have one side of parallel sides. This one is called an isosceles trapezoid. And what's specific about it is the sides that are not parallel are equal. Okay, so the two sides are parallel, and then the sides that are not parallel, so this is what's called an isosceles trapezoid. That is a trapezoid with the non-parallel sides congruent or equal if you want to go with that. Okay, so basically these are all the different ones we've looked at so far. Whoops, that's a parallelogram. rectangle, square. So if you have a square, all the things that are true about these are also true about the square. Okay. This is isosceles, this is a rhombus. If you have a rhombus, whatever's true about parallelograms and trapezoids is also true. Okay, so we'll kind of sum up this whole unit and put down all the things that we've looked at for this. And again, you can use that on a test because that's a nice summary. We'll have a nice summary of all the different things we found that are true. Okay, we are actually going to look mainly at isosceles trapezoids. Okay, so what we can tell if we have an isosceles trapezoid, some things that are true. Oops. It's not drawn very well, but you know, it's supposed to be the same. Okay, if these are your two congruent sides, just like an isosceles triangle, the base angles are going to be the same. So basically, if you think about this, if you added those up to a point, it would be an isosceles triangle. And so the base angles would be true, would be equal because of that. Well, this is just the portion because we put a parallel line right through there. We make two isosceles triangles, one smaller, one bigger. And so that's really why you get that. So the base angles are congruent. Now, if I wanted to, I could flip this over. Okay. If I flipped it over and made the short side my base, like this, okay, and these are congruent, these are also considered base angles. So both pairs of base angles are actually equal, okay? So the top pair and the bottom pair of the angles are equal. It's just, we call it base, but base is just whatever it's sitting on. And usually we draw one of the parallel sides as the base, as the bottom, okay? So both of these cases are true, which really gives you this. If I have a triangle or isosceles trapezoid, okay, then this pair of angles and this pair are congruent. So it's basically the ones on the parallel lines. Now, the other way we could show that is kind of like this. Because these are alternate interior, they equal 180. You can see that's gonna work out like that. Okay, so that's where that kind of comes from. Okay, so the base angles we know are congruent. One thing we can always say. The other thing we can say is when we draw diagonals in a trapezoid, what would happen? Oh, isosceles. They'd be equal, that's right. Then they would be equal. So if we draw, I can't draw it, isosceles triangle, well, isosceles trapezoid. Okay, and if we draw these, they will be equal. Will they bisect each other? Do they bisect? Yes, they will bisect each other also. Okay, because if they're equal, they're going to cross at this will be equal to that. No, they don't bisect each other. Never mind. They do not bisect each other. Okay, it would be the top ones are congruent and the bottom parts would be congruent. Okay, so they don't bisect, but they do form vertical angles with the top pair being equal and the bottom pair being equal. Okay. So those are that's basically 7-5. It's all about trapezoids and what you can figure out from them. But again, these all have those same things that we can say about them. Okay, but we already know based on what kind of shape they are, those things are true. We already know that diagonals are equal in rectangles and stuff. So that's the whole thing about 7.5. You have a question?
Just wondering, what happened to the white one?
I don't know. I went to talk to Miss Sagert to ask, and I have not found her yet. Yeah, I was surprised today.
Okay.
Very surprised. So yeah, I'm like, okay, I need to find out what's going on here. I thought we had permission for that, but
Definitely. For the middle schoolers for tomorrow.
well, I hope not. But okay.
With the teeth, girl.
Someone look at a strong prejudice against Wentworth.
It's probably the pastor.
I thought we had permission, so.
He's the force.
Yeah, now it looks worse. Cause they didn't take the sticky.
It looks like it's
photos.
insanely humid.
It looks like it's really humid.
Ew. Oh, yeah, it does.
Okay, this next one, 7.6,
Everybody's sweating.
is kind of a weird part to throw into here. The reason it is kind of what I just showed you from finding the trapezoid that's part of a triangle, okay? So what we find out is that if I take a triangle and I take a well, that's not, but if I take the midpoints of two sides, this will be parallel to this, okay? So these are the midpoints of the two sides of the triangle. And what you find out is that they're parallel. This and this are parallel. So it's the line between is parallel to the base. Okay, does that work for any triangle? Draw a couple triangles and see, does that work for any triangle?
Wouldn't it? I think it would have to be isosceles or equilateral.
I'm asking you, draw some pictures and see.
Figure this out.
Draw some different triangles, see if I connect the midpoints of two sides, will it always be parallel to the third? Or to the others,
Wait.
yeah. Draw any triangle.
I think it works.
Wait. That's so cool. Wait a minute.
Can we find life hacks?
Hold up.
So connect the midpoints.
Uh-huh.
Midpoints of two sides of the triangle.
Edit.
And the line between is parallel to the base. So if
Wait.
you take that,
So half the height?
it's not half the height, it's the midpoints. So these are the midpoints. So that's equal, these are equal. So if I draw a triangle like this, okay, and I take the midpoint of this side, which is about there, and I take the midpoint of this side, about there. Are those parallel?
Yes, they are.
They are.
That's
Look at
crazy.
that.
That's insane.
The midpoints of any two sides of a triangle is connected, is parallel to the third side. That's true of any triangle. I drew it as an isosceles because that's the easiest to see. But yes, it is always true.
The secrets of the universe.
The secrets of the universe. But they can use this to measure a lot of different things. Okay,
Extremely useful.
pardon?
That's extremely useful.
Yeah, it is extremely useful.
Really
Okay.
figure this out.
Okay.
Yeah, it is.
You can look at it. So that's always true. This is for all triangles. Not just any kind. It's true for all triangles. Okay. So if you find the midpoints, connect them, that will be parallel to the other side. Okay, that's always going to be true. Okay, so we're going to start. I'm going to give you some time to work on these. Actually, yeah. Let's go ahead and take a break. 10 minutes, come back at 25 after.
I don't have